Choir music.
Choir music, but nicer than this.
A very warm welcome to you to the next Hi-Ace 4-wheel drive 48 volt van video. Today is a big day. Feverish work with our Hi-Ace 4-wheel drive van, but the big news today, of course, is the 48 volt hub. The project to make 48 volts accessible for everybody. And this is the very first production unit being manufactured in Western Australia. In my excitement, I did jump ahead with the story. There were quite a few things that happened before Heine got to fit it for the first time.
You know how 105 amp hour batteries used to be the standard in the industry? Well, we're back to that. This is a 105 amp hour battery, but it's 48 volt and it's lithium and not AGM. And they are the new Egon certified 48 volt Amtron batteries.
It is a revolution in DC power distribution.
This is what's gonna go into the van with communication. So the idea is that these batteries will tell the alternator how they want to be charged, and they can then set that charge. And the cool thing about that is that that system is the way it should be designed, because the battery knows how it wants to be charged, and the battery should be telling the other components how to charge the battery. Egon 48 volt certified means that the set of instructions in these batteries, how they communicate, how they want to be charged, are compatible with our system that we've designed.
That's about the same weight as AGM.
Yeah. Compared to 50 amp hour AGM or 105 amp hour AGM, that's got 8 times the energy capacity. And it's got a vent port, so you can install it inside.
This is vented according to Aussie design rules, venting as it comes.
And it works together with the 12mm John Guest bush fittings.
That is a very impressive piece of kit. Look at how good it looks. Choir music.
Choir music, but nicer than this. This is version 0.2. Maybe this will turn into version 1.0. Let's see how the test goes today.
Remember, these products that we're demonstrating on the van, including the bull bar and the roof conversion and the rear bar and of course the 48 volt system, these are pre-production testing. You are, and this is very unusual, because when companies do this, they protect themselves by not showing this bit. So when you see something fail, the proper reaction is, cool, they're learning stuff, because it's only through failures do you learn. And I'm going to give you the perfect example of that. During our trip, of course, we've driven this all the way from Perth to Melbourne, all the way from Melbourne to Sydney, Sydney to Brisbane, and drove it all the way back, testing these various systems. And there's a shot of me struggling with the roof conversion. Some mornings it's a little better than others, but to pack this up, you know what would be really, really useful here? And because we were an integral part of their development team, we spent the entire trip crossing Australia, testing it and trying it this way, trying it that way. And Heine came up with the following solution.
You might not even need external clamps anymore, because you can clamp it internally.
And we know that Ollie, who's developing this, you weren't that happy with that outside clip. Yeah, hopefully we can help you work on a solution.
We'll think about something very complicated and then leave it to you to design and develop that.
So, proof that this process works. What have Headspace campers done?
need to improve on this side, but self-latching, self-rubber squashing.
And the cracks that occurred in the bull bar.
I mean, all we want to do is take the movement away.
That's some people reacting, saying they don't know how to make bull. Here's some truth. There's actually a shot, and here is Heiner.
Mounts to the axle carrier, and then this bolts to the front of the chassis.
Test fitting a brace that was part of the design of this bull bar, but there was a mismatch in the prototype holes we had to leave on our trip, and so we decided not to fit it. But we thought, hang on a minute, if we don't fit it and it fails, we'll learn something that we might not have otherwise learnt. Where is the weakness in this bar without those braces? This is why we're here, and hopefully this is why you're watching. Now what we're going to do is, part of the 48 volt system that we had limitations on, well, we had quite a small battery in the high ace that for the 48 volt alternator and system was charging, and we couldn't stretch the charging ability. That's a major advantage over 12 volts. 48 volt charging rates are 4+ times faster, more efficient. We couldn't test it all the way because the little battery couldn't accept the current we were trying to give it. And we knew that that was going to be the second stage of our testing, and now we have the battery that can. Now you're actually going to wire it up.
I'm gonna wire it up again like we did last time, and ideally without the voltage spike suppression exploding like it did last time. Oh shit.
That wasn't good. Right, so you've beefed that up. I see everything is quite a lot heavier than it was before.
Yes, we've learned from what has happened, and there's lots more protection here now. And this is the section that will prevent load dump scenarios in the future. Let's see if it actually does.
Now, the 48 volt system that we're designing, you can use any 48 volt battery, lithium battery, and it will work perfectly. But some configurations have to be put into the battery, so the charge rates, etc., are optimized. And these batteries, signified with the Egon 48 volt certified logo, this one made by Amtron in Western Australia, means that they have been pre-configured. They're smart batteries. The internal battery management system is clever. It's also in a case which is optimized for Australian design rules for venting. So you don't need to put this in another case like you might have to do with an ordinary battery. It's delivered in a case. All you need to do is vent it with a simple vent. So the simplicity that Heiner's demonstrating at the moment, just simply running cables and putting them in and tightening them up, is exactly what the final product will be. That simple. You do not need lugs, you do not need ferrules, you do not need heat shrink, so that's going to save an enormous amount of time and effort in wiring it up. You simply use the extremely high quality clamp connectors built onto the hub board. If you follow the instructions, it will work first time, every time. All of the smart, clever wiring done for you. While Heiner does that, I'd like to show you some other work that we've done on the van. Something different in the background today.
Yes. I have a feeling I'm going to get used to it. I like the roof.
I'm spending the morning, of course, those of you unfamiliar with where I am, this is Sean's place, Mission 4x4. He's better known for troopy accessories, including his lovely gull wings. The reasons for fitting a gull wing to this are not the same as why you would fit a gull wing to a troop carrier. And these are the problems we have to overcome. I mean, a gull wing here is all very well, isn't it? You know, but once it's open, I then cannot open the slider. So I have one. So whatever is going to be stored in here is the kind of thing that you might use while on the road. For example, maybe recovery equipment and things like that. Tire pumping equipment. But not cooking, not something that you might want to access while in camp, because while in camp, the slider's open. And the other side has a similar challenge, and that is that it's on the wrong side of the van, because the kitchen, the living area, is on the other side. So what would you use this for? Now, my thoughts are that this would be the perfect place to put a water outlet for having a shower. You have a certain amount of privacy because everybody's on that side of the vehicle, and now, like with troop carrier, the shower is on the opposite side of the living area. And I'm fitting both. Not that I think I need both, but I want both because I want to learn about how useful they are and what are the drawbacks of having them here, and are they really needed at all, etc.
You know why all auto-electricians are such attractive individuals?
I hadn't noticed, but tell me.
Because you have to be a yoga master at the same time to fit into all these spots and be able to contort yourself. So
Oh, really?
Yeah.
That's why they look the way they do?
that's why we're so good looking.
I'm giving up my yoga mega membership if that's the case. Well, that same little light came on,
Okay,
which is a good sign.
let's say it is.
It's a living thing.
I hope it's not a deja vu. Let's hope it will just connect without blowing up. I'm probably shaking more than last time. Nothing's exploded. That's definitely a good thing.
That other light has come on. And that will go out once the fuses have been removed.
Okay. Now we need fuses. Boom! So for now we keep this battery connected just so that we replicate the system exactly the way it was the last time. So we know this is working, we know how it's working. Do a little bit of testing with it. Then we're gonna disconnect that battery and connect that battery and see what happens from there on, step by step by step by step, so that we know exactly where we're coming from and where we're going to. Never change two things at the same time, then you never know what caused what.
Let's get the tool with
Now, the Mission 4x4 gull wings for troop carrier require no drilling. But this is a different scenario because with the troop carrier, the original glass is removed and this is put back. There's no cutting required, and he's used this very clever clamp system. But we have a much thinner material. We don't have the bracing that you get around the troop carrier. This is a very strong part of the car. It's very rigid. It's not the case with the van.
original design is being a prototype, so I made it narrower, and that's why we have a lot of gaps still. So it's better to start with a narrow window. We fit it, we test it, and then if we decide to make it wider, we have more material to cut in the future, so which it makes it more practical for us. Nice. Yeah. Okay, so now I'm very happy with the 3mm. Fits really nice.
You need me to turn accessories on, yeah?
Yes, please. Yeah, the vehicle supply is turned on. Start
Now,
the engine.
Start the engine. Oh, that's a good looking smile on your face.
That's doing things. 2.5 kilowatts just idling alone.
All right, very good.
Battery is actually quite flat, so means we can get a fair bit of charge into it and just really test it for a while. Voltage is quite low. We can use my special test tool for it. This thing is good for hydraulic lines and for keeping the throttle pressed down. Holy moly! 4 kilowatts, eh? That is as much as the battery can handle. That is maxed out again because the battery cannot handle more. We're at maximum charge voltage, maximum we allow at the moment. Very nice.
Let me explain a little bit about what's happening. That battery has, like all lithium batteries, a maximum charge capacity. In other words, the internal battery management system limits the speed, the amount of current, the amount of energy that goes into the battery and is stored. Because lithium, if it is not controlled, well, it'll catch fire. That is why these batteries have an internal battery management system. So now the system has maxed out that battery. So we have now a second moment of truth, is that we are now going to connect our new big battery, which has more than double the capacity and can accept more than double what that can accept. We are now going to test the system to see if it'll do what this bloke says it'll do.
1000 RPM and it's 3.5 kilowatt. The engine is on high idle. I think another thing we have to develop for this is a little controller to turn high idle on. 1200 RPM. Something that works better than a spanner. I'm grounded here with my finger. This is definitely grounded. I'm gonna touch live 48 volt now to showcase. I think I have to be sweating to really feel that. I've got a feeling I'm feeling it a little tiny bit, but if I'd be sweating, I'll definitely feel that. Look, it is flat out at 70 amps now. That's the maximum I've allowed it to do because we haven't got temperature control on the alternator yet. I'm gonna go and check the temperature of the alternator. In the future, there will be a temperature probe on the alternator itself, derating it once it reaches a certain maximum allowed temperature to make sure the unit itself is protected from overheating. Look, and we are only at this stage. The utilization of the field is at 67%. I think if that would be at 100%, we'll be pumping 100 amps into the unit now. Look where we're at with the charger already. We started at 30 something. Well, we've been at it for 5 minutes and the battery is at 52% already. We are now continuously charging with 3.8, 3.9 kilowatts. For you guys to understand how much that is, if you take a 15 amp plug that you put into your Caravan, the maximum power you get out of that is 3.6 kilowatt. So the amount of charge we're putting in from the alternator now would blow the fuse for the 15 amp plug where you connect your Caravan. It's more power than that. And we're still only at 2/3 of what this thing is capable of. Oh, I'm not reading the manual. I'm just looking at what sensational job the guys at Amtron have done. Good manual. Not that I need the information, just looking at it. Good letters too.
Nice font.
And very nice font.
And now, with the new battery connected, what's going on?
I'm waiting for that Servo GX to boot up, because right now the battery is connected to the Servo GX with a CAN bus connection, which might take some configuration to actually show up there. Oh, or might not. Find out about that in a second. That's already good that there is something at all, because this shunt is not connected to anything anymore now. So with this system in the future, you don't need an external shunt anymore. You use the battery internal shunt. And all it is just another data communication cable and one less thing to wire up. Just ground directly into the hub. Positive through a fuse holder that's just floating around here now to the hub. Data comms cable in, mission accomplished.
It is also valuable to know that with this system, DC-DC chargers are obsolete.
Yes.
They are not required.
It has come online, so I can see everything that's going on. You can see battery voltage, state of charge, state of health, battery temperature. I can see lowest and highest cell voltage, individual cell temperatures. Nice. Awesome, that was so easy. But it's still not showing anything on the display here. That part I don't quite understand. Cool, that is working very well. It's just not showing on the main screen. Look, at high RPM we still got 25% more to put on top, which means 25% more will be at 5 kilowatt, what our benchmark is where we want to get to. But I want temperature compensation before that happens, because I don't want to fry the alternator. So now we're at really low idle, so the utilization of the field has gone up to 100%, because now at idle the alternator only produces at about 1000 watt, because it's gotten really hot already.
Know what's incredible about this? Look, look at this. Little cable, little sweet little cable.
Yeah, and it's not even warm. You know, if you would have done that with 12 volts, you'd need 000 BNS, which is 95 mil square cable, and it will get warm, especially where the fuse connections are, where you've got surfaces touching. It'll get really warm. They're so warm you'll burn your fingers on it. This is a success. It's exactly how we thought it would be. Next step will be that the battery will actually tell the alternator exactly how it wants to be charged, what voltages to run, what currents to run, and the alternator will respond to what the battery wants it to do. That's the last step of the whole mission.
So from this point, we're going to continue the testing, but we've come up with a problem. It's a unique problem. Okay, it's charging too fast, because we've got to get the van here for the next row of testing. We've got to get the van here with this battery empty.
And we want to test.
So I could park it at my house, drain this battery with the lights on and everything, and drain the battery. By the time I've driven here, it's full again.
Yeah. What a problem to have, eh?
So,
and then it will take us all day to flatten it again.
It'll take us the entire day to flatten it again, so we can test it.
Means we need an inverter. It's about time to hook an inverter up to this thing.
It is, to test it. We do need to do that. That's the next stage. So the next stage actually is to take what we've shown you and install it in an actual vehicle. It's actually going to be this one, because we're having this beautiful interior made where we will have 2 of these batteries, and all of this installed as if it had come out of a workshop. All right, with a nice big fat inverter. And with all of the cables, because there are jury rigs here and there as part of our research. Brand new installation.
Yeah, get rid of everything, start fresh.
Literally start a fresh installation. And you're going to train the guys at Elevate as you do that, as part of that process. But we still need to crank this up to see if we can, and this will be hopefully in the next episode, our challenge was we want to charge that battery in 1 hour's driving from 0 to 100%. That's what we're trying to do.